our teammates is Candice, Yu Yixuan, Chong Wei Shan, and Lim Yong Sing. And I'm Lim Yong Sing. I'll be first introducing some basic knowledge about vector. So vector is a geometric that have both magnitude and direction. So in this line, the length of the arrow represents the magnitude of the vector, where the arrow is pointing for direction. So as the vector is only representing magnitude and direction, so negative a is vector that have the same magnitude as vector this blue arrow vector. This is the same magnitude as vector a, but it is pointing the opposite direction. Besides that, you can do addition using vector. The diagonal of the parallelogram that starts from the same point as the vectors represent the resultant vector. So in this case, a plus b have the same results as b plus a, as it's using the parallelogram to represent the addition of vector a plus b. Magnitude of a vector can be calculated using the formula below, which is square root of x component of vector a squared plus y component of vector a squared. There is also a cross product for the vector, which is another vector that is right angle to both vector a and b, which means this is the cross product of vector a and vector b. So this is the formula for the calculations of cross product of a and b, where this a is represent the magnitude length of vector a and b represent the magnitude of vector b. This theta is the angle between vector a and b. Dot product is a way to multiply two vectors to get a scalar, and this is the formula to get dot product of vector a vector b. So the vector is really useful for daily lives and also applications. For example, we can use it to calculate how much force should be applied at each direction to make a system work as required. And also vector can be used to analyze lift, drag and thrust force on aircrafts. Besides that, vector can be used to predict weather patterns by calculating the wind speed and different direction. To make a better understanding in vector, we have prepared 3 questions, and question 1 is about the airplane flying horizontally due north in calm air at 300 miles per hour when it is encountering a horizontal crosswind blowing southeast in 40 miles per hour and also a downdraft blowing vertically downward at 30 miles per hour. So we need to calculate what is the resulting speed and direction of the plane relative to the ground. So we have to first draw the diagram for it so we can know that which is the direction. So this red line represents the flying force, means by the force on the plane that is flying to north, which is 30 miles per hour, and this is the crosswind acting on the airplane, which is to southeast in 40 miles per hour. And also this green line is the downdraft blowing vertically downwards at 30 miles per hour. Okay, so we have to calculate the component y of this horizontal crosswind. It's at southeast, so it's 45 degree towards y, and this is from the purple line to east, it is 45 degree, and the length of this is 40, so we need to find the y component. So we use the trigo formula. Cos 45 is equal to the y component of this crosswind divided by 40. So we'll get that the y component of this vector is 20 sub 2, and also we need to find for the x component, which is sine 45 equals to x divided by 40. So we'll get x is also equal to 20 sub 2. So this is the vector form for this force. Because it is actually a 3D, so we have 3 components in one vector, three variables. And this is the vector form for the downward draft vector. So we need to find, so in this one will be the resulting speed and direction, this blue line. So we are finding this one, which is actually the sum of these three vectors acting on it on the A plane. So it's the F vector plus this C vector plus D vector. So we can use the formula, which is the F vector plus C vector plus D vector, and then we'll get our final resulting vector. And this is the direction of it, and so we still need to find the speed of it, which is the magnitude of the vector. So this is the formula of it, which is same as just now, the formula shown. So it is the square root of x component square plus y component square plus z component square. So in the formula it will be shown like this, and then we'll get that speed of the resulting force is actually almost equal to 275 miles per hour.
For question 2, calculate the wind velocity for the situation shown in the figure. The plane is known to be moving at 45 meter per second due north relative to the MS, while its velocity relative to the ground, which is the total velocity, is 38 meter per second in a direction 20 degrees west of north. Based on the description, we can label the diagram as shown. The plane will move in a solid arrow labeled v total, which is the vector sum of velocity of wind Vw and the velocity of plane Vp. So first of all, for the velocity component in still air Vp, since the plane is only heading north at 45 meter per second and there is no any horizontal movement, Vyp is equals to 45 meter per second and Vxp is equals to 0. For the component of the total velocity, since the plane is moving at an angle of 70 degrees from the ground as shown in the figure, the x component of the total velocity is equals to 38 cos 70 degree, which is 13 meter per second, and the minus sign in front is indicate the west direction movement. For the y component of the v total, it is equals to 38 sin 70 degree, which is 35.7 meter per second. As mentioned previously, the v total is equals to Vw plus Vp. So to find the x component of the wind, we can say that it is equals to the x component of v total minus the x component of Vp, which is minus 13 minus 0, and you get the x component of the velocity of wind is equals to negative 13 meter per second, while for the y component of the wind, it is equals to the y component of v total minus the y component of Vp equals to 45 minus 35.7, and the final answer of the y component of velocity of wind is negative 9.3 meter per second. To get the magnitude of the velocity of wind, we can simply use square root of x squared plus y squared to get the answer, which is 16 meter per second. While to get the direction of the velocity of wind, we can use tangent theta equals to y over x, which is negative 9.3 over negative 13, and the angle is equals to 35.6 degree. Therefore, the wind is moving with a speed of 16 meter per second at an angle of 35.6 degree. So now question 3 is about application on adding force vectors. The question asks us to calculate the sum of the two forces exerted on the boat by workers A and B in figure. And figure B shows the free body diagram of it. We add force vectors like any other vectors. The first step is to choose an xy coordinate system and then resolve vectors into their components. The solution is the two force vectors are shown resolved into components in figure B. We add the forces using the method of components. The components of FA are FAX and FAY, which equals to FA cos 45 degree and FA sin 45 degrees. Then we'll get the same answer, which are 28.3 Newton. And next, we find FBX and FBY, which are positive FB cos 37 degrees. Then we got
the answer positive 24 Newton. And Fby equals to negative Fb sine 37 degrees. Then we get the final answer, negative 18.1 Newton. Fby is negative because it points along the negative y-axis. The components of the resultant force are Frx and Fry. First, Frx equals to Fax plus Fbx, which equals to 28.3 Newton plus 24 Newton equals to 42.3 Newton. Next, we have Fry equals to Fay plus Fby equals to 28.3 Newton minus 18.1 Newton. We get the final answer, 10.2 Newton. And to find the magnitude of the resultant force, we use the Pythagorean theorem, which is Fr equals to square root Frx squared plus Fry squared and equals to square root 52.3 squared plus 10.2 square Newton and equals to 53.3 Newton. And the figure looks like this. The only remaining question is the angle that the net force makes with the x-axis. We use tangent theta equals to Fry over Frx equals to 10.2 Newton over 52.3 Newton, and we get the answer 0.195. The next step is tangent inverse 0.195 equals to 11 degrees. So the conclusion is the net force on the boat has magnitude 53.3 Newton and acts an 11-degree angle to the x-axis.
That's all from us. Thanks for watching.